There we go. So tonight we're looking at 2.4, which is complex numbers, and we'll just pick up and carry on from where we left off the other night. So we'll do 2.4 and 2.5 tonight. And what opens this weekend? Matter of fact, what opens tomorrow? You test, right? So, yep. All right. Here we go. We're going to be getting into I, and I is the square root of -1. We'll look at complex numbers, and complex numbers are nothing more than numbers that can be put in the form of a plus bi, where a and b are both real numbers, and I is imaginary. The standard form of a complex number is a plus bi. You've got the real part and the imaginary part, guys. We talked about conjugates the other day for a binomial, right? It's the same binomial, but just with a different sign. It's basically like a difference of squares, right? So if you're familiar with that, with binomials, and you should be okay. So that's all vocab. And the square root of negative numbers is you can't take square root of a negative number. So how do I deal with that? You basically are breaking the factor down to square root of -1 times that number. And that square root of -1 is I. All right? Questions? Y'all good? Here we go. All right, so write the following in terms of I and simplify as much as possible. Well, what I said was we're going to rewrite the square root of -4 into the square root of well, let me do this, square root of 4 times the square root of -1, right? And I told you that square root of 4 is what? 2. And then the square root of -1 is nothing more than I. So that's what it basically boils down to. So that would be 2I. Questions? So we're not doing anything different than how we approached it last week. We broke it down into factors, right? And one of the factors now, if we have a negative underneath, will be square root of -1. And that's going to be our imaginary component. Okay. All right, so we got minus square root of -18. Folks, I'm going to just go ahead and tell you, put that 1 there, because if you don't, your brain is going to see something and you're going to drop it or miss it. That's the most common mistake. So what we'll do is we will take -1 times the square root of -18. And of course, to simplify the square root of -18, we're looking for a perfect square to be a factor. And in doing so, that would be square root of 9 times the square root of 2, and then times the square root of -1, right? And then we also have that -1 that's out front. So when we simplify this, we're going to get -1 times 3 times the square root of 2 times I. And of course, with the commutative property of multiplication, we can move things around. So we put I in front and leave the radical in the end, right? So that's going to leave us with -3I square roots of 2. So that's going to be this. And note that I was already in there. Okay, so that's what they're wanting. Questions? Anybody? Y'all good? Yeah, mighty quiet. You're either really tired from a long midweek, or you're gelling on some stuff, which is good. Okay.
Second line.
Yeah. It's -1. It's the square root of -1, because the square root of -1 is I. Because I equals the square root of -1. So those two are synonymous as far as they're the same. You can substitute it in. Yeah, Dex, go.
Can you say again why -3 has the I?
Oh, well, I don't want to leave anything behind the radical. If it's out of the radical, I need to put it in front of it. So it's basically acting like a coefficient, right? So I wouldn't leave the I back there, because some people would think, well, maybe that I goes underneath here, underneath the radical. So you bring everything that's out to the front. I just probably should have brought the -1 out here, out front, and done it, but with the way my brain was going, I just went perfect square and all that other stuff. So this probably should have been right around in here, right? Yeah, and that's what it moved to the front. All right. Holy snap. Find x and y, so 4 plus 3i equals 12x plus 6yi is true. Oh, okay. So we're trying to find what x and y would be in order to be the same as that, right? So what would we need to do to 12 to make it 12 times what would make it equal 4? A third. So that would be 12 times a third would equal 4, right? So the x would have to be a third. And then what do we need to do to to y, to 6 times what would give me 3, right? So that's kind of the same thing, but that would be what? 1/2. That's exactly right. 6 times what would equal 3, right? I'll just put that there. So that would be 6 times 1/2. And I just brought the imaginary part along there. Not too sure why that problem's there, other than they thought it was a good problem. But pretty simplistic as far as they're just looking at what would it take to make both of them equivalent. Y'all good? No? All right, so basically here, we need to make the left side equal the right side, right? Okay, so I need to make something times 12 to be 4, right? So what can I multiply 12 by to get it to be 4? 1/3. So that's why I put what times 12 equals 4. 12 times 1/3 equals 4. Yeah, it's kind of, we're sitting here rocking along dealing with square root and -1s, and then they go, here, let's just throw something in there odd. And then they say, what times 6 I would equal 3i, right? So that would be, of course, 1/2, right? It'll hit you going on the way home tonight. Just don't swerve off the road. Police report. Figured out what we were talking about in math. All right. Yeah, sorry. Yeah. All right. So there's, I think, only 1 or 2 graphing problems. So I just want to make sure we're good on this. And I'm not gonna lie to you guys. I had to look back because I normally don't deal with graphing complex numbers. Okay, I just don't. So here's what you need to make sure you understand. You've got a real and an imaginary part, right? Yeah. So the x-axis will be real, and the y-axis will be imaginary. So basically what we have here is -5, -1, right? Y'all agree? Because there's a 1 right here. Are you okay with that? So with that understanding being there, then this would be what? -5, -1 would be right there. Yeah, that's basically all you're looking at. That's the real, it's the real part.
So your x
Is your A.
but it'll always be the real number?
Yeah. And your Y would be the B, right? In the A plus BI, right? The real part would be the x-axis, and then that would be, so let me do this. That's the A, and that is the B. That may be a little bit better. Let me do that. Does that help you a little bit? And there may be 1, maybe 2, I can't remember. I definitely know they're not more than 2 if there's more than 1 on there. So anyway, Y'all good? Yeah. It ain't going to say I minus 5. It'd always be in the form of A plus BI. Let's say this. What if it just said, is it locked? Why be? What if it just said 2i? What if it just said 2i? What would be your coordinates? What would be your order pair if it just said plot 2i? 0, comma what? 2. Because you wouldn't have any A, right? The only way you represent A would be with a 0. So, does that make a little bit? That's about as crazy of a case you can see. Good question, though. All right, so for the following exercises, perform the indicated operation, express the result as a simplified complex number. Now, when you go to subtract these or add these, you do like terms. You understand, like terms. So, here we go. And what I mean by that, A and A's and BI's and BI's, right? I put this problem in because the most common mistake is when people forget to distribute that -1, which essentially all it does is it just changes the signs in the expression. Okay. Yeah. If there's no number there beside an operation, it's always 1. Yeah. And that's why I put it there. And I've done that. It just depends on how much your brain or your eyes is trained to tell your brain what to do. So now I just take the -4 and 3. That gives me what? -1. Now I take the 1i, right? And the -5i, and that gives me -4i. And if you looked, I put 2 lines under the complex like terms and then 1 under the A, the real parts, right? Any questions? Okay. All right, when you multiply, we've got a binomial times a monomial. Guys, I just rewrite it as a monomial times a bi, right? We're just so ingrained in doing that we just need to make sure that we follow suit. And then, of course, we just go ahead and distribute. Now, these we don't have to worry about, right? We don't have to worry about keeping them real and real and imaginary. You're just multiplying them. So 4i times 5 is 20i. 4i times -2i is -8i what? Now, let's go over here. We need to make sure that we understand that I is what? The square root of -1, right? Now, I squared would be the square root of -1 squared, which is what? -1, right? It takes care of the square root, right? Yeah? Okay. So this would now be 20i minus 8 times -1, and that would give us, I'm going to go ahead and 8 plus 20i, because that would be a negative times a negative, which would be a positive, right?
If like say you were just going down and you left it as 20i plus 8, is that all right?
No. Complex number systems in the form of A plus BI. Try it and see, just for grins and giggles. But I'm pretty sure they're probably going to hard code that. They may not. I don't know. But I'd be surprised if they don't make you do that.
I got a question. On the homework, it's like they give you the perimeter and then you solve for a number, and I can't get any of them right, but then when I plug in the values, I can get them right. I don't know. That doesn't make sense at all, but.
On the word problems things?
You know, like when it says solve for a variable.
Yeah.
So it's a 2-part question.
Yeah.
The first part you solve for a certain letter, and can't get any of them, but then when you substitute the numbers, then I can get them off.
Mhm.
That's weird.
You got to think about terms of solving equations, and you're solving literal equations, and you're thinking about, okay, I need to move things, so that's either addition or subtraction, and then when I get things isolated, now what's happening to my variable that I need to solve for? It's either being multiplied or it's being divided, and then you just follow suit from there. After class, I throw a perimeter one up there, and we can do L and solve for L and solve for W, and I can look at where you may be going astray, what you're getting confused about. Because literal equations, we're so ingrained to solving regular equations, we just don't get enough practice in that. And sometimes when you're throwing a bunch of variables in there with no numbers, it messes with you. So we can look at that after class if you want to. Don't have a problem with that. All right. Yeah. So I'm going to teach you how to do multiply binomials the way that I do. And it's nothing more than FOIL, right? First, outside, inside, last. But I'll show you how it's come about. So I always do the first term times everything in the second parentheses. Okay? Then I take the second term, which is plus 3i, and I multiply everything in the second parentheses with that. Now, this separation is nothing more than what you would have done if you would have done this, right? Y'all remember that? Do your I hate to say arches or rainbows or whatever you want to call them, right? Over -2 times -5, -2 times 3i, right? And then you'd have 3i times -5, 3i times 3i. Well, when you split this, that's really what you're doing. That's how it came about. Now, that separation right there is nothing more. If you think about, you remember factoring by grouping? We have basically 4 terms, and you're looking to pull out a GCF, right? So you have something over here, right? So, and that first parentheses has to match the what? Second one, right? Y'all remember that? So that's basically what you're doing. You're using that same principle. You're reverse engineering is what you're doing. But that's how FOIL came about. Yeah, yeah. Yeah, and you'll miss something. When you do it like this, here's the real cool thing about this. When you split it like this, it works for any type of multiplying of any polynomial you ever got. You can have 6 or 7 terms in this one times 6 or 7 terms in that. You're still going to do it with the same approach. First term times everything in the second, then second term times everything in the second, third term times everything in the second, parentheses, so forth and so on. So it's kind of, you see the pattern and the process, and it kind of flows a little bit easier. Okay, so, and then you just distribute. And every time I press down on this, it's giving me little dots, and that's about to drive me crazy. So -2 times -5, put that up here, would be 10. -2 times 3i would be -6i, right? And then 3i times -5 is -15i. And of course, 3i times 3i is 9i squared. Now, this is a pattern. When you do this, you're going to have the same things come up all the time. You're going to have like terms right there. And you're going to have to do something with this joker right there. This last term that's an I squared. Because I squared is -1. So basically what you would do would be 9 times -1, which equals what? 9, right? So you can kind of do that math right there. Oh, it would. Sorry, I jumped the gun. Thank you. Yeah. Oh, we are. We're going to rewrite I to the 40th and stuff like that. We'll rewrite powers of I, or we'll evaluate powers of I. And I'll show you how to do that as well. Yeah, it's not that bad. Actually, it's pretty easy, I think. But my easy and your easy are 2 different things. See, like with Al, his easy is Automotive. Ain't my easy. Huh? No, I can take care of them. Do that. I don't have to be good at everything, but I need to know who to go to get the answers. That's the difference. All right, so we've got 10 here and -9. And then, of course, guys, we have -6i and -15i. So when we clean this up, 10 minus 9 is what? 1. And then -6 and -15 is what? Nope. -21, right?
Now you're subtracting from negative. Like, so we're going backwards.
Well, yeah. Yeah. So, yeah. Which part? All right. So we know that's -9, right? And its like term is 10. So 10 minus 9 is 1. This I squared is always going to be there. And you have to take care of that, right? Because I squared is negative what? 1. So 9 times -1 is -9. That's kind of like a rubber stamp. Chink, chink, going to happen every time. Yeah, not a problem. All right. Mm-hmm. Until we get into quadratics, which is, yeah, next section.
So as you progress, your variables start to have a whole lot more meaning.
Yeah, we're picking up different content, different levels of mathematical understanding. Yeah, you're adding to it.
In the whole code thing,
In the what now?
the coding, is that how that works? Like you're using a whole lot of
This?
numbers? Yeah, like it's like all the time.
We're not doing binary. Nope. All right. So when you see a binomial raised to a power, the easiest thing to do is don't fall into, oh, that's just a power times a power, right? Just 1 squared, -1, all that, and then be done. That is not how that goes. A power tells you how many of those you have. So I have 2 1 minus i's. And if you'll write it out, you'll be less likely to make that same mistake. Because I guarantee you that'll be a mistake. So here we go. We're going to split it. I'm going to go up here. 1 minus I, and then -I, 1 minus I, right? Y'all see how I split that? First term times everything in the second. Second term times everything in the second parentheses. So I'm going to distribute. So that's 1 minus I. And then that's minus I and plus I what? Squared. So these are going to give me what? -2i. Good job. And this is just going to give me what? -1. So what's 1 and -1, guys? It'd be a 0 minus 2i, right? Which is nothing more than what? There you go. Basic polynomial multiplication, right? But we're doing it complex numbers. So the only thing you've got to make sure you understand is I squared is -1. All right.
And when we see the negative square root -1,
You could.
I know you said earlier.
Yeah, you will when you get solving quadratics, which is where we're headed in the next section. It's right up there in front of shoot. William?
No, I'm not talking
Yes.
about that. You gave us the negative, the I.
Oh,
Square root -1/4.
yeah. I'm going to do all of them to power 4, up to power 4 in just a second. Yep. All right. I put this on here because it's a meat and tater type question. It's a lot of stuff going on, so you got to make sure you know what you're doing. So we have a complex number in the denominator. So we can't have that. So we have to multiply top and bottom by the conjugate. Okay, the conjugate is going, its whole purpose is to create a situation where that particular component goes away. And if you look at that denominator, you'll see that that is a difference of squares, right? Same numbers, just different signs, right? So we know the middle term, which would have an I, would go away. So here we go. So not only do we have an opportunity to multiply one time, we have an opportunity to multiply twice. Yay us. Right? So let's just go over here, then we'll go to town on this. And there. Yeah, first term times everything in the second parentheses, second term times everything. That way you make sure that you are getting everything, right? Yeah, same principle, same process. So that's going to give me 20 minus 20i minus 25i plus 25i squared. Okay. This is going to give me, 25 minus 25i plus 25i. You see that middle term canceling there? And then, of course, negative 25i squared. All right. So let me grab some stuff to kind of clear some stuff up. This is going to be 25 times negative 1, right? Y'all good with that? And then this will all be negative 45i. Y'all agree? Yeah? So this, good. So 20 minus 25 would be negative 5 minus 45i. And now I'll go green down here. These drop to 0, and they should always. And then that's negative 25 times negative 1, which is positive 25. And 25 and 25 is what, folks? 50. Now, we're going to have to simplify this so that you know what's going on. When you have a binomial over a monomial, two things over one as a fraction, you can split it and rewrite it, right? Or you can keep it all as one fraction and then realize that, okay, I have to find something, if it's reducible, that will go into all three of those, right? So 5 will go into all those, right? So if I pull a 5 out of those, that's negative 1 minus 9i all over who? 10. And let me move that dot in case there. So this is what you have right here. Since they have that written like this up here, they're probably going to make you do this. They're going to make you split it. They're probably going to make you split it, which basically take this first term over the denominator and the second term over the denominator. Just by the way they have it right here. It does, but they're both the same. It just, what representation do they want as an answer, right? Yeah? And that's what you have to figure out. I don't have a clue. Sorry. Anybody done homework on this one yet? No? Me neither. Yeah. Oh, Lord, yeah. Ask F class. Yeah, it's not a problem. We can do that. All right. It'd just be plus negative 9i over 10. Because remember, when you subtract, it's keep, change, opposite, right? That's really the laws of subtraction, right? We keep the first number, change it from a subtraction to an addition, and then change that next number from a positive to a negative, right? It'd be double signs is basically what you're doing. Plus, minus. We just have a tendency to not get into that trend, right? Yeah? All right. How many more we got to go? Man, why did I ever decide to do this one? How many? Just 2? Yeah. Okay. All right. So I'll give you 15 seconds to look at it in your mathematical endeavors. You'll get there, I promise you. All right, guys, so here we go. We're going to take this square root of negative 32, and we're going to split it, and we're going to say the square root of negative 1 times the square root of 32, which we're going to reduce to the square root of 16 times the square root of 2, guys. Now, why 16? Because 4 went into it. We tried 16. 16 goes twice, so it's a little bit easier to simplify it from there. So the square root of negative 1 is I. The square root of 16 is 4. And then square root of 2, we can't simplify that. So, and I don't leave it as I times 4. It's 4I square root of 2, right? I normally goes after the number. Now, so let's go back up. We're going to go 2 plus 4I square root of 2 all over who? Now, I'm going to show you how to split this. Now, this is kind of elementary, but make a heart and break it.
So you don't have to do the negative 2 times.
No, because 2's the number, right? 2 can be in the denominator, right? So that's basically 2 over 2 plus 4I squared to 2 all over what? 2. And I know that that's elementary and stuff, but it sticks, folks. Trust me. 2 over 2 is nothing more than 1 plus 2I square root to what? 2. Questions?
So it's 2, but just
Yeah, they did. 2 over 2 becomes 1.
because I just cancel around that and just simplify this.
That 2 is over both of those. That's a binomial over a monomial. So that 2's over that 2, and that square root of negative 32 is over that 2. So you just can't do.
I simplified the radical right, but that's just what I said.
Yeah. And that's why I drew that. See that heart? 3rd graders love that. They do. That came from my wife. Yeah. 3rd graders and 5th graders love that. Yeah. She taught me that. So I'm just teaching y'all. Because one day, guess what?
You're gonna have 3rd grade?
Lord willing, y'all have 3rd graders and 5th graders. And Creek don't rise. Right? Yes, ma'am. All right. So that would be 1. Oh, my bejeebies. I see what you're doing. Okay. Because they hard-coded the I in there, look what I done.
How are you able to do that?
I just wrote it in.
We can't do that though.
Oh, yeah, you can. Yeah, you can. Yeah. Oh, I'm not making this up. Come on now.
You can take that I and slide it in there like that.
No, that I is hard-coded in there. So they're telling you that I has to be this part over here. And the I is there. So you're not having to put the I in there. So if I can't put it like 1 plus 2I squared root of 2, then I've got to do 2 squared root of 2 times I, right? It's kind of like 1 times 2 times 3 is the same as 3 times 1 times 2, right? Same thing. They hard code that thing in. Now, it's not the preferred method of representation, but it'll work. So remember, it's a program to input math. So it's going to be cray-cray. Okay? It'll be a little cray-cray. So just bear with it. Just go with the flow. All right, here we go. Yeah, all right. Favorite ones. Y'all ready? This is great. No, y'all not? Y'all don't like this? Really? What if I told you it's as easy as counting to 4? What if I told you it was as easy as dividing something by 4? Would you believe me then? All right, so, oh ye of little faith. Pay attention, here we go. I to the first is nothing more than square root of what? -1. I squared is what? -1. I to the third is nothing more than what? These two multiplied. Negative square root of what? -1, right? Yeah? And of course, I to the fourth is nothing more than what? 1. Now I'll tell you something. Most people will tell you to rewrite it in terms of I squared, won't they? How many of y'all remember you math teacher saying, rewrite that thing in I squared. Break it down into 2's. Y'all remember that? I know you do. It's echoing in your head, right? No, y'all don't remember that? It's like flush, brain dump, right? Yeah, I'm with you on that. All right, listen. I always teach it for you to rewrite it in terms of I to the fourth. Because, guys, the reason I tell you to rewrite it in terms of I to the fourth is, what's 1 raised to any power? 1. So I don't care if you raise 1 to a gazillion. It's still just 1. So it makes life a little bit simpler. You got teachers that are headstrong. You do it to I squared. You wrong if you do it any other way. Well, they just foolish. Yeah. We call that ignorance to the highest power. All right. So how many times, watch this. This is great. How many times will 4 go into 40? Thank you. It's a power to a power. And that would be 1 raised to the 10th, which equals what? All right, we're going to do another, and I know where you're headed. Okay, go. Sorry.
No, you know what I mean? 'Cause I was going to say, if you wrote, I did the homework on this question. I to the 31st.
Yeah, you'll do it? Let's do it. You want to?
I mean, yeah.
Yeah, let's do it. We got to do another one.
I was gonna say that you have to write it in a specific way on the homework.
Okay.
So
It's not as easy. Okay.
negative, square root of -1.
You won't?
So,
What is it?
well, I guess I didn't try it. I wrote.
Okay. Well, there ain't no next one, right? Y'all said that was it. Oh, yeah, we're going to. We're going to nerd out, yeah. Y'all ready? All right, any questions about this? Y'all see how I wrote this? Now, so, listen. 4 is going to go into it evenly, or to go into it with a remainder of 1. Hello? 1 times that is what? Square root of -1. Right? Or just I. I squared would be a remainder of 2, right? I to the third would be a remainder of what? And then I to the fourth, boom, done. So it's either 1 or these, right? That's it. So that's what I to the fourth gives you. I know we're going to look at it. So I to the 31st, right? You good? All right, so we're going to talk. Okay. Because I don't know how they want us. Man, they might want us to stand on our head and input this. So I took 37. Oh, sorry. 31st. How many times will I to the fourth go into 31? 7 times. With how many left over? How about that? Now, what is I to the fourth? 1. What is I to the third? Square root of -1, right? Right? So that's going to give me, anybody? Negative square root of negative what? 1. Really? Oh, Yes. Yeah. Okay, I'm with you. Yes. Okay, let me back up. This should be negative I, and that would just be what? I. Yeah. That's why. You're right. Go back and fix this, because I just left him as this. I didn't convert him back. So he's right. He's absolutely correct. So it'd be I, -1, negative I, and what? 1. I just left it as this, right? Negative I. That's the same as that, right? Okay. And this is the same as that, right? I had the first number with I. You're right. You're absolutely correct.
Well, I just want to point that out in case if they tried to input negative square root of 1, but I don't have, it's still right, but you had to put it in the I.
Yeah. Yeah. And that I should have done this. You're absolutely correct. Yeah, good catch. So I to first decimal I cubed is negative what? So your answers are only going to be this. Look. I, -1, negative I, or what? 1. In your remainder, 1, 2, or what? 3. Boom, done. Because what's 4, which is 1 raised to any power? So it's just 1 times these, right? Okay, good. All right. I like that. So, questions? Y'all good? Maybe. Maybe. All right. Oh, to the problem? Sorry. It is this well, let me fix this, because I need to fix this. I to the third is nothing more than negative what? So that becomes what? Negative I, right? 1 times negative I, which is negative I, right? Right. So, excellent. All right. Let's